Hi there, and welcome to another update on the volcanic eruption going on in Iceland. I am Geology Professor Shawn Willsey. Today is Monday, August 26th. It's about 9:30 a.m. here in Idaho, 3:30 p.m. over in Iceland, and our eruption is now on day 5 since it began last Thursday, August 22nd. And the activity is concentrated at the northeast end of the fissure system, just like we saw the last few days. It's diminished considerably in intensity over what we saw during that initial day or so of the eruption. But we're going to run through some of the data. There's a new update from the Met Office, which has some great information along with a map of the flow field, which I'm always excited and anxious to see. And so let's just get started here. So you can see through the webcam here the more or less extent of the eruption as it currently stands. Looks like this leftmost vent might be a little bit angled or is partially blocked because it's jetting lava a little bit at a little bit of an oblique angle here instead of straight up. And so we still have this small section of the fissure system that seems to be active. And so this ridge of material built up here, it's not really a true spatter cone because we have more than one vent. When we get to just one primary vent and that lava that's being jetted out starts to become distributed more or less symmetrically or close to symmetrically around that vent, that's when we see a true spatter cone forming. Right now, this is what we call a spatter rampart. It's more of like a ridge, a linear ridge of material, in this case lava that's been jetted out, falls back down to the ground and just sticks and starts to accumulate. This material is something we call agglutinate once it accumulates on the ground here. So you can see the extent of the eruption right now. Estimates of the height of this spatter rampart are anywhere from like 20 to I think 40 or so meters tall. Kind of a rough estimate. I'm sure we'll maybe get some better ones going on. And some of these fountains go up maybe 80 meters or so into the air, something like that. I didn't check that right before, so you can probably hunt around at the different webcams and chats and get some different estimates there. But you can see the activity as it stands right now. I think there are still some moss fires burning associated with the lava flow. And so let's look at one more view here. So a couple of views here on the Life from Iceland camera. Can't see much here in the distance. Except for some of the gas coming out. This is Stora Stogafelt here, the hill that you're looking along the flank of, and then you can see some of the jetting here. Here it kind of looks like one specific vent, but that's because you're looking along the trend or along the axis of the actual fissures there. So let's get right to the Met Office update, excuse me. Let me make that a little bit larger for you. So this just came out literally a few minutes ago as I was preparing this update, so good timing. And this appears to be, based on their estimates, the largest eruption in this area along this lineament that we've seen, since this activity began last fall. The largest in terms of the volume of lava that's been erupted. So this appears to be so far bigger than the other eruptions we've seen. So beginning of the eruption, estimated the lava flow is around 1,500 to 2,000 cubic meters per second. Now it's obviously slowed down quite a bit. So just like all the other eruptions, it starts with a bang. A tremendous amount of lava erupts along the length of that 4, 5, 6 kilometer fissure. Then things start to die down to what we see going on today. Yeah, so the thickness of the lava about 40 centimeters or so, so half a meter. That's probably average over the whole area. All measurements indicate this eruption will be the biggest since fall 2023. They've got the area of the lava bed estimated about 15.1. I'm assuming that's square kilometers. And then I think the gases and the winds carrying those gases off to the south as it has the past few days. I'll get to the map here in a second. All measurements show it's the largest since fall 2023. Eruption continues in the area northeast of Stora Stogafelt, so that area, that far northeast end of the fissure system. During the last day, the activities become somewhat isolated in one area north of that fissure. So let's take a look at the flow field map here quickly. Get that a good size so we can kind of take that in. Maybe start with the big view here. And you can see, let me go a little bit further out. So here's Grindavik down at the end. You can see the various colors of purple and gray, but the brightest purple here is the extent of the flow field from this most recent eruption. The red line here is the area where the fissure is still erupting. Remember when this opened up on August 22nd, we had a more or less through-going or series of fissures that extended from here all the way just a little bit south of Silingerfeld down to about this point here. Thankfully, none of those lava flows, because this was directed further to the north. We didn't see a lot of that lava moving south towards Grindavik, so the town very much has been safe since this eruption began because of the location and the direction of those flows. Some of these lobes initially, when the eruption started, we saw lava flow lobes advancing to the west and northwest. Looked like they were going to cover the roadway and possibly present a issue to the power plant in the Blue Lagoon. But after 12 hours, 24 hours into the eruption, that fissure system kind of waned in terms of its output, and the lion's share of the activity, was concentrated here in the north. So you can see here where the flow field from this fissure has kind of wrapped around this area here and also this here. There's one topographic feature here, Lilla Skogfelt, that sticks up, and so it's kind of wrapped around, I guess 2/3 of it onto this part here. These lobes are advancing slowly to the north and a little bit to the west, but quite slow, and there's quite a bit of big open ground here. So my guess is that a lot of this will just sort of fan out, and it's not going to advance rapidly towards either this roadway here or the primary road to the north. Let me switch views here to kind of show you a bigger view, since the Met Office map cuts off a little bit here. So I don't have the lava flow field on here yet, but the primary location where we're seeing the eruption taking place now is this little section right here to the northeast. And so we've got lava flowing around this hill, Lilla Skogfelt, and probably about to this point here. So this is more or less the northern extent of our lava flow field, and it's still quite several kilometers distance out to the main road here. This is the primary road in Iceland that takes people to and from the airport. It connects this area of Keflavik and some of these towns here in the airport with Reykjavik and other parts of Iceland there. So still, early enough that it's something to keep an eye on, but just based on the output of the volcano as it currently stands, and just looking at some of this topography here, it's very doubtful that the lava flows would make it that far. We'll have to wait and see. Anything's on the table, but that would be my best guess right now. This is a very flat, mostly flat open area. There is, of course, a regional slope down towards the coast here, but it's quite gentle, and so there's a lot of room for that lava to kind of fan out, spread out, and it's always more difficult to get that lava flowing farther at its distal end when the vent is way back here. Of course, we know it can do that with lava tube systems where it crusts over on the surface. So again, still early, still a hazard, but I'd say a fairly low risk at this point of anything like that taking place. Let's go back to the Met Office update. They've got some more stuff here. They talk a little bit about the output here. Right now it's probably only several tens of cubic meters per second. That's down quite a bit from the initial output when the eruption began of close to upwards of 2,000 cubic meters per second. So it's a small fraction of what it was when it began. They talk a little bit about the thickness of the lava and the aerial extent of the lava, and so they calculate that about 17 to 27 million cubic meters of magma have left the storage system in the subsurface, the magma body, since the eruption began. So it's actually erupted a good chunk. I mean, well over half of what was originally down there. So it's erupted quite a bit. We'll get to the GPS data later, so we'll just kind of skip through that. What else do we have here? It's not possible to state about the continued flow of magma until the magma accumulation area until land is visible again. Not quite sure what they're saying there. Yeah, earthquake activity is low, and then they talk a little bit about the winds, and then there's an update to the risk assessment map with basically that fissure region and along that northeast trend there, that being the primary concern, and that's the highest hazard level with these two red areas adjacent to it, slightly elevated. So there's the Met Office update, and I'll make sure I put a link to that in the description. There was also a great 360 drone shot that was put together by Horder Kristofsson, and his name's right here. I probably butchered his name, but this is a nice view here. Here we are looking to the south. So here's the erupting fissure. This was taken on the 24th, so this was on Saturday, a couple days ago. So you can see more of the vents and fissures active at this time. This, of course, has died down a little bit, and we're really just seeing a much shorter section of this segment erupting still right now. But here's the gases. Grindavik way off in the distance, can't even quite see it. Blue Lagoon and the power plant over here. You can see all the moss fires here along the edges of the lava flow where it's igniting the moss and maybe some of the grasses there as well. Here's where some of the lava went around Lille Skogfeld here. Airport out in the distance, so that's the view to the west. And now we'll swing around to the north, the town of Vogar. You can see the coast there. Again, the leading edge of the lava flows where the moss fires are. Strong winds from the north on Saturday, and then kind of swinging around to the northeast. Reykjavik off in the distance, this prominent peak here, Keilir, and then looking to the east at the Fragodalsfjall area over in this region. So great job from Horder for this nice image that we're able to kind of see everything. You can just kind of grab it, drag it, and pull it, and kind of check it all out. 360 view, very cool. Let's see what else. Let's check out earthquakes. So last 24 hours. Let's start in the eruption area. Typical of what you'd expect to see, when it's still erupting. Mostly very small earthquakes, although there is one. Uh, Maybe it's gone now. Maybe it was over 24 hours ago. There was one too, but I think it was maybe yesterday, so it's not included in this data set. But there's 5 magnitude 1 and above quakes in the last 24 hours. And then if we add all, we see a few more. But it's an ongoing eruption. Things there's collapsing. There's changes in the conduit system. All of these likely responsible for some of these small magnitude quakes that we're seeing here. And then we did have in the last 24 hours, unrelated to the ongoing eruption, was a larger 3.6 quake, very deep. Well, for this area, over 7 kilometers depth, over here east of Lake Klevervat, and just a bit east of this Krishuvik system, this system of volcanoes in this region here. So, and then lots of probably aftershocks, reactions to this bigger quake in this region here. So nothing about this says that it's magmatic or related to magma movement. And here's where the eruption zone is here. When we look at the past week or so, and I did some of this analysis on our last update, but the colors on this just showed up so nicely, I thought we would maybe revisit this again. So remember that the size of the circle is the size of the earthquake. Bigger the circle, bigger the magnitude. How big are these big ones here? Well, that biggest circle you can see there was a 4 or 4.1 that occurred the day of the eruption. So most of these are pretty small. But what we can see here with the color coding is this is the when it occurred. So blues would be about a week ago. Getting into greens and yellows, that would be about 4 or 5 days ago. And then as you get into yellows, oranges, and reds, that would be within the last 3 or 2 or 1 days. And what you can see here is a week ago, which would have been before the eruption, you can see a lot of the earthquakes kind of distributed, somewhat scattered a bit down in this region here. And then once we got into the eruption proper, or just before the eruption, you can see more of these kind of greenish yellow quakes concentrated at the south end of the fissure system, just here next to Selingarfelt, here at the east end of Stora Stogfelt, and then up here is where the eruption ended up really concentrating. And we saw that dike actually propagate up to the north and open a new pathway as that new fissure system moved to the northeast on last Thursday and going into Friday. Here's the small little hill, Lille Skogfeld here. And then today's eruptions over the last day or two would be all these red and orange quakes here. So you can see a lot of those just concentrated right in this little region here. So that's where we're at with earthquakes in the region. These will probably continue, these small magnitude quakes right around the eruption site while that's ongoing. But overall, we expect to see earthquakes and earthquake activity dissipate a little bit. So we'll probably see a few more days of this pattern, which can look alarming when you just see all the yellow there. But when we kind of weed out, those tiny earthquakes, it doesn't look quite as ominous. And that's what we might see moving forward a bit. GPS data shows what we've typically come to know is true for these systems, where we have the initial, let's get to the 4-hour run here. Let's start with that one, I guess. So here is the inflation that was going on throughout July. A little gap in the data here when things were offline. Continued inflation, you can see this steady rise. This is the elevation of this GPS station up and down. So it's moving upward. So as more magma is moving into the ground, that's causing the land to literally rise above it. And we see this not just at this GPS station, but at a dozen or more in this region. And then you can see when the eruption began here last Thursday, as magma left the subsurface system and moved up to the surface, coming out of the ground as lava, you can see where this dropped down. And so we had a down drop here, and it might trend down there's a little bit of a downward trend here, but eventually this will probably turn around and move back up, because we have no evidence so far that suggests that more magma is not moving into that shallow storage zone from depth. It's what we've seen in the past, and in fact, just to kind of remind you of how this looks big picture, let's go to the same station, but let's look at it over a 1-year time period and just look at like what this looks like over time. So here is down here on the bottom. Here we are back in last fall, so literally a year ago, no movement at all. Then magma started to move into this shallow subsurface magma storage zone. You can see the uplift, the inflation that culminated on November 10th with the flurry of earthquakes and magma injecting itself into a subsurface dike, an actual vertical curtain, if you will, of magma that trended southwest northeast. So then the ground dropped a little bit, quite a bit actually, and then it started inflating again as more magma was being pumped into that system. That culminated with the December 18th eruption. Another one on January 14th, small hiccup here, is in a little bit different location, so the down drop was not as pronounced. The February 8th eruption right here, March 16th, if I'm getting my dates right, May 29th, and then notice the May 29th one, there's this little hook here, right? So it actually showed some deflation initially, but then it turned into a strong inflationary trend that continued through the summer up until last Thursday, August 22nd, when we saw the eruption begin. So we're right here at this point, and it's very likely that these next set of points over the next few weeks and possibly months will largely mirror what we saw after the May 29th eruption. And so until there's any evidence to the contrary, that would be the best hypothesis for what we're going to see moving forward. So some of the GPS data, the interferogram looks pretty cool for this time period as well. So if we choose this one here, so the satellite went over the area on the 17th of August, which was before the eruption when we were in a state of inflation, right? And then the satellite went over the area again yesterday on August 25th. So if you think about, well, what's happened between August 17th and August 25th, a time frame of 8 days? Well, we had an eruption. So the land was swelling. It was high on the 17th. Then we had the big eruption on August 22nd. And so the land has sunk since then. That's what we see with all of these GPS measurements here. And so the satellite goes over the area, bounces radar waves off of the ground, and so it detects the distance, and then it goes over again on the 25th to detect the distance, and it's of such a precise scale in terms of measuring, that it can measure even these small differences. And so what we get here is this really cool view of the with the interferogram. And so here, this is more or less the center of the uplift we saw. Well, we had uplift, but then it deflated, right? So after the eruption, all the magma moved out, well, a lot of the magma, excuse me, moved out of this subsurface storage system and was erupted over here. So here you see a nice clear bullseye. Each one of these colored fringes represents a certain amount of vertical motion, up or down. In this case, it's down, so you can see how much there is here in terms of downdrop. And then it gets a little murky over here because this is where the eruption was. So notice these nice colored rainbow fringes start to get a little bit distorted in this area, and that's because this is where the lava came out of the ground. You can actually sort of make out the extent of the lava field on the interferogram. You can trace out this distorted, where it sort of interrupts the nice colored pattern here. That shows you more or less where the lava field is, because the lava field would be putting lava on the ground, building up the land. Some places are a little low, some places are a little high, and that's why it's quite messy here. But you can actually more or less make out in a very crude manner the extent of that flow field on the interferogram, which is very cool. So cool looking at that data there. So anyway, I think that's about all I have for our update today. We will continue to monitor things looking forward. What do we expect? What should we be looking for? I think the webcams are going to give you the best view of just the conditions. If any folks get drones up like Isaac, you could watch some of the footage of flying over the vents. We can see what changes might take place. I would expect that possibly these multiple vents that we're seeing here, there's a little one down here, might coagulate and concentrate into one single vent as the eruption volume wanes over the next few days, and then we might start seeing a more symmetrical, aesthetically pleasing spatter cone develop moving forward. But for now, we have these cool spatter ramparts. We have multiple vents erupting lava. That lava's piling up, building up the sides of this thing. We might see pieces of it collapse. Remember, these spatter cones and spatter ramparts are a constructive and destructive process that kind of goes back and forth. The lava falls on the area around the vent, builds up these cones or ramparts, but then they can get too heavy. They're not structurally very stable. They can collapse. The vent itself can undermine and compromise some of the slopes, and so you can see things collapse back into the vent. So there could be inward collapse, there could be outward collapse. Lots of cool things could happen here as we just kind of watch this spectacle take place over the next few days and potentially weeks. So other than that, watching the GPS and watching to see if we start seeing that uptick, if we turn around this slight deflationary trend, and if it starts to become more of an inflationary trend, that will be clear evidence that we have more magma in the deeper zone that's pumping back into that magma storage zone. And then once this eruption dies down and ends, then we'll be more or less resetting the clock for the next eruption, which could be, most likely months away, could be weeks away. We'll just kind of have to see how things look. Also, maybe checking to make sure these lava flows that are very slowly creeping to the north, let's see if those actually fan out, or are they going to maybe do something a little more crazy and maybe follow some channel and make more direct progress towards the roadways. That's worst case scenario, but that's bears watching as well. So lots to keep track of in the next few days and weeks to come. I'll provide these updates as best I can as we move forward. Hopefully these were helpful to you, help you understand what's going on, and I appreciate your support of the channel. Thanks for being a learner here along with me, and we'll see you next time. Take care.